Hi everyone. So today we're going to work on our laws of exponents and how they apply to rational exponents, as well as doing some simplifying using those laws and rational exponents. Okay, so at the end of today we're going to be able to use our laws of exponents to simplify some rational exponent expressions. So what we need to remember is our laws of exponents. So if you remember way back in the day, we did work with our laws of exponents. And things that we have to remember with this is they only apply to things that have the same base. Okay, so you can only apply the laws if both bases are x and x, or 4 and 4, or 5 and 5, or y and y. Okay, and that's only for when you're multiplying bases or dividing. Okay. You can do your power to a power if they're multiple bases, or if you have more than one, a product being taken to a power. So here are our laws. So let's look at them. For any real numbers a and b, any rational exponents m and n, for which a to the m and a to the n and b to the m are defined. Okay, so meaning that we're just saying it's all mathy legit, like all the rules are appropriate. Okay, so here we have a to the m times a to the n. We add. Okay, multiplying, add if the bases are the same. Dividing, notice that we're dividing here, we're subtracting, and again, subtracting exponents if the bases are the same. Here we have I call it a power to a power. So raise power to a power, multiply the exponents. And if we have a product taken to a power, so raise the product to a power, each one, everybody gets one. Okay, so just because our exponents are fractions does not change the fact that these laws still apply. Okay, so nobody said that they had to be integers. Okay, all right, it just says rational. Remember, rationals are integers or fractions. So we're going to use the laws of exponents to simplify. So here we have 3 to the 1/5 times 3 to the 3/5. We can do this problem because the bases are the same. So that means that we're going to add our exponents. So 3 to the 1/5 plus 3/5. Okay, that gives us 3 to the 4/5. Okay, now if these guys right here, these two 5s, were not the same, we would have to find a common denominator so that we can add the two fractions. Okay, all right, let's come over here. All right, so division means that we're going to subtract. Our bases are the same, they're both a's. So that means I'm going to subtract 1/4 minus 1/2. Notice that to subtract these, I'm going to need a common denominator, which means that 1/2 is going to become 2/4. Okay, so this is a to the 2/4. Got a little ahead of myself here. 1/4 minus 2/4, which is equal to a to the negative 1/4. Again, I'm not a big fan of the whole negative thing, so we're going to move it, right? Remember we talked about that. So it's going to be 1/a to the 1/4. There we go. Now you can make it the 4th root of a, but we're perfectly happy with 1/a to the 1/4. Okay. All right, let's try this one. I don't know why I left so much room. Okay, 7.2 to the 2/3, whole thing taken to the 3/4 power. So here we have a power to a power, so we're going to multiply. So we have 7.2, 2/3 times 3/4. Okay, so we can multiply that straight across. So we're going to get 6/12, and we can reduce that and make this 7.2 to the 1/2 power. In fact, that reducing thing is going to happen a lot, and that's one of the things we want to get used to doing. All right, here we have a product to a power, but we also have exponents. So that means everybody gets one. So a to the negative 1/3, and we're going to times that by 1/2. And then we have b to the 2/5, and we're going to times that by 1/2. All right, so if we multiply straight across, we get a to the negative 1/6, b to the 2/10. Again, we can't have a negative. We don't like negative exponents. So we're going to have b. So the a to the 1/6. Let's do that first. So we're going to go a to the 1/6 is going to go in the denominator. And I'm going to change that 2 over 10 to 1 over 5. There we go. Okay, so we're going to apply all these rules, these same rules that we had before, to fractional exponents. Okay, now the reason why we want to do that is because when we talk about simplifying things, some rational expressions, sometimes it's easier to put it in, go from radical to exponent and deal with it that way and then put it back. Okay, so we're going to want to write it in exponential form first. Okay, so this is when we're going to use this. I figured we might write to. All right, so we're going to convert it to exponential. Then we're going to use our laws of exponents and just basic arithmetic, you know, things like that to simplify. And then we're going to put it back to radical. Okay, so we're going to go from radical to rational exponent, clean it up, and then go back to radicals. Okay? All right, so let's start here. All right, so we're going to write this as a radical. So we get 5x to the 3 over 6. Again, where I'm using my parentheses. So 3 over 6. Now, we can reduce that to 5x whole thing to the 1/2 power. And then we're going to convert that back to the square root of 5x. Okay. All right, let's come over here. So we have t to the 20th, the whole thing taken to the 5th power. So we're going to convert that to 20 over 5. Now 20 over 5 is 4. There's no radical to reduce to change it back, so our answer is just t to the 4th. So it's a lot easier to look at it as 20 over 5 than it is the 5th through the 20. Okay, so here we have the cube root of ab squared c, whole thing taken to the 12th power. So I'm going to use my parentheses here. So remember our index, our root is the denominator. So 12 over 4. Okay, so let's reduce that first. So ab squared c, 12 over 4 is 3. Okay. Now, right? No, I got ahead of myself. That should be 3, not 4. There we go. Okay, now we're going to use our properties of exponents where a product being taken to a power, everybody gets one. So a to the 4th, b to the 8th, c to the 4th. All right, let's do one more. Wow, that looks really nasty. All right, so let's start with the inside and work our way out. Or, yeah, let's start on the inside. So this is the square root. I'm going to make that x to the 1/3. Okay? Now, square root's 1/2, so we get x to the 1/3 to the 1/2. Now we have a power to a power, which is x to the 1/6, because 1/3 times 1/2, which is the 6th root of x. Looked really nasty until you started working from the inside out. Wrote cube root of x is 1/3. Wrote square root to 1/2, multiply, because a power to a power, that's what you do, and you get the 6th root of x. All right, guys, short video today. Let me know if you have any questions. Please stay safe out there, and I'll talk to you again real soon.